In 2015, a citizen scientist found a star that shouldn't exist. The star drops in brightness by 22% at random for reasons nobody can fully explain. For 100 hours, the world's most powerful radio telescopes pointed at it, listening for signals. They heard nothing. They are still listening. This is the only star in modern history where mainstream science published in a peer-reviewed journal the possibility that it might be surrounded by alien megastructures, and 11 years later, we still cannot fully rule that possibility out. The story begins in 2009 with NASA's Kepler Space Telescope, a spacecraft built to do one specific thing: stare at a single patch of sky for years on end and record how the brightness of every star inside it changes. Kepler was looking for exoplanets. When a planet passes in front of its parent star, it blocks a tiny percentage of the star's light. Most exoplanets cause dips of about 1%. The largest ones, Jupiter-sized worlds, produce dips of around 2%. Kepler logged the brightness of 150,000 stars, taking a measurement every 30 minutes for 4 years. The data set was so enormous that NASA could not analyze all of it. So in 2010, they created the Planet Hunters Project, a citizen science platform where volunteers worldwide could review Kepler light curves visually and flag anything strange. In 2011, a Planet Hunters volunteer flagged a curve from a star called KIC 8462852. The light curve was bizarre. It did not drop by 1%, it dropped by 15, by 20, by 22%. The dips were not regular, they were not periodic, they were not the shape of a planetary transit. They were unlike anything anyone in Kepler's archive had seen. The volunteer flagged it. Other volunteers flagged it. Eventually, in 2015, the case reached a young astronomer at Yale University named Tabetha Boyajian. She and her team analyzed the data systematically. Then they wrote a paper. The paper was published in 2016 in monthly notices of the Royal Astronomical Society, one of the most respected journals in the field. The title was carefully neutral: Planet Hunters X KIC 8462852. Where's the flux? The astronomers had ruled out almost everything. The star itself was, by all measurements, ordinary, a normal F-type main sequence star, hotter than the Sun, a bit larger but otherwise unremarkable. Its position in the sky, its surrounding environment, its history, nothing suggested it should behave the way it did. Worth pausing here. A 22% drop is enormous. A Jupiter-sized planet transiting in front would block about 1% of the light. To block 22%, you would need an object, or many objects, covering nearly a quarter of the visible disk of the star at the same time. Whatever it is the size of stars or larger. The first serious explanation, included in Boyajian's own 2016 paper as the leading hypothesis, was comets. Specifically, a massive swarm of broken-up cometary fragments recently disturbed from a distant orbit, passing through the line of sight in irregular formations. The cometary hypothesis was plausible. Comets are dusty, opaque, and travel in elongated orbits. A close encounter with a passing star could have disturbed an entire population of icy bodies in Tabby's outer system, sending them inward as a chaotic stream. Different sized fragments at different distances would explain the varied shapes of the dips. The irregular timing was consistent with comets, which do not follow tidy orbits. For 2 years, comets were the accepted answer. Astronomers wrote follow-up papers refining the model. Comets were physically reasonable. Comets were boring. Most importantly, comets were not aliens. The problem was that comets did not actually fit the data. In late 2016 and into 2017, a series of observations chipped away at the cometary hypothesis. Spitzer Space Telescope follow-up observations led by Massimo Marengo at Iowa State University found no infrared excess around the star. If the dimming events were caused by clouds of warm comet dust, that dust should be glowing in infrared light. It was not glowing. Then, in 2016, Bradley Schaefer at Louisiana State University reanalyzed historical photographic plates of the star going back to 1890. He claimed the star had been gradually fading for over a century, losing about 20% of its brightness over 120 years. The comet hypothesis required a transient event. A century-long fade was something different entirely. Other astronomers disputed Schaefer's analysis, but the point stood. By 2017, the consensus inside the field was that comets were not the answer. Something else was happening. And the longer it took to find an explanation, the more astronomers began entertaining ideas that, in a normal paper about a normal star, would have been laughed out of the building. In 2016, an astronomer at Penn State University named Jason Wright published a paper in the Astrophysical Journal. The paper had a long, careful title, but the core of it proposed something that no mainstream astronomy paper had ever proposed before. Wright argued that the dimming events at KIC 846852 were consistent with the signature of artificial megastructures orbiting the star. Specifically, structures large enough to harvest a significant fraction of the star's energy output. Dyson swarms. The concept, first proposed by physicist Freeman Dyson in 1960 as a thought experiment about advanced civilizations, was being applied to a real star in a peer-reviewed journal with serious math. This was extraordinary. Wright's paper was not a fringe document. It was published in the Astrophysical Journal, one of the field's top-tier outlets. The mainstream of astronomy had, for the first time in its history, opened the possibility of alien megastructures as a real hypothesis worth investigating. The SETI Institute responded. They directed the Allen Telescope Array, a system of 42 radio dishes in Northern California, to listen to Tabby's star for narrowband radio emissions, the kind a deliberately transmitting civilization might produce. They listened for 100 hours, covering frequencies from 1 to 10 gigahertz. They detected nothing. The Breakthrough Listen initiative followed up with the Green Bank telescope. They also detected nothing. For the public, the story exploded. Tabby's star became, briefly, the most famous star in the sky. Media outlets called it the alien megastructure star. Boyajian, the discoverer, gave a TED talk that became one of the most viewed astronomy talks of the decade. Honestly, this is where the science became uncomfortable. Astronomers do not like proposing aliens. The discipline has strict standards against jumping to extraordinary conclusions. But the data was, and is, extraordinary. The current leading explanation, accepted by most researchers in the field today, is irregular interstellar dust. In 2018, Boyajian led a follow-up paper using observations made during a fresh dimming event captured in real time, using the AAVSO network and multiple ground-based telescopes. They found that the dust blocking the light was wavelength dependent. Blue light was blocked more than red light, the signature of fine particulate matter, not solid objects. Solid objects like planets or megastructures block all wavelengths equally. A separate paper by Hans Deeg at the Instituto de Astrofísica de Canarias proposed that the dust was orbiting the star in a complex, irregular cloud structure, possibly remnants from the breakup of a moon, an asteroid, or even a stripped exoplanet. The dust theory accounts for most of the observations. It is consistent with the wavelength dependence. It does not require aliens, it satisfies Occam's razor, but it does not fully account for everything. There are dimming events whose shapes do not match any straightforward dust cloud model. There are gaps in our understanding of how the dust cloud got there. And the century-long fading reported by Schaefer remains debated. Nobody who studies this star is fully comfortable with the current answer. Here is what matters about Tabby's star, regardless of what the final answer turns out to be. For the first time in the history of modern astronomy, the mainstream scientific community published a peer-reviewed paper that seriously proposed alien megastructures as a possible explanation for an observed phenomenon. Not a science fiction thought experiment, a real paper with real math about a real star in a top-tier journal. The community responded the way science is supposed to respond. SETI listened. Spitzer looked in infrared. Spectroscopic data was collected. Historical plates were reanalyzed. Bit by bit, the alien hypothesis became less likely, and the dust hypothesis became more likely. Not because aliens are impossible, but because the data started to point elsewhere. But, and this is what makes Tabby's star unique, the alien hypothesis was never formally ruled out. There are still events in the light curve that the dust model does not cleanly explain. The star continues to be monitored. The Allen telescope array continues to listen in case anything changes. Most of modern astronomy never has to consider this kind of question. Tabby's star is the one place where, briefly, science had to face the possibility that we were not alone, and we had just looked directly at the evidence. KIC 846285 is one of 150,000 stars Kepler observed in the direction of the constellation Cygnus. To the naked eye, it is invisible. Through a backyard telescope, it is a faint dot. Even in Kepler's archive, it was just one of 150,000 data streams. But for one specific star, for reasons we have not fully explained in 11 years of trying, the universe has been doing something it should not be doing. Every few years, the brightness drops, sometimes by 15%, sometimes by 22%. The drops happen at unpredictable intervals in unpredictable shapes, and we still cannot say with certainty what is causing them. Astronomers are still watching, they are still listening, and somewhere, on a server farm in Berkeley, the Allen Telescope Array's data archives quietly grow. Thanks for watching, and I'll see you in the next one.